Welcome in another video. Today we are going to discuss the reactivity of the first transition series. Here we have Scandium, which is located on the left side of the first transition series. Scandium, let me write it, Scandium 21. Iron, which is located nearly in the middle of the first transition series, Fe26. And copper, Cu, which is located at the end of the first transition series, copper 29. Scandium, which is highly active since it can react with water, H2O, to give scandium hydroxide, SCOH by 3, plus hydrogen gas. So scandium here can, in a single replacement reaction, can replace this hydrogen, since scandium is more active or is really highly active than the hydrogen, so it can replace it and it can give the scandium hydroxide plus hydrogen gas as in this equation. So let me write it. Scandium has high, let me write it in another color. Scandium is highly active. However, iron has a moderate reactivity. So iron actually can react with the oxygen from the air in the presence of water to give the iron rust, FeOH by 3. This reaction actually takes up to 3 months. 3 months to occur. So iron has a moderate reactivity. Actually, I didn't write the balancing of these equations. You can balance it easily, right? If you have any problems balancing it, please let me know in the comments below. However, copper is actually or has a limited reactivity. Let's say limited reactivity. So, for example, if there is a copper to react with water, there is actually no reaction, right? Why? Because copper, as we can see, also is in the bottom. Copper is below hydrogen in the electromotive series, right? So let's say sodium and below it calcium. I'm not sure about the oxidation potential. I'm just giving you a picture. So let's say this is the hydrogen, which is the borderline, and here you can find that the copper is below the hydrogen, the electromotive series. Copper cannot replace hydrogen, right? But sodium can replace, for example, hydrogen. So copper, in this case, has a limited reactivity. So to summarize it, as you go from the left side to the right side, you can see that the reactivity of the first transition series decreases. And this actually makes sense. If you look at the group of copper, you have Cu, and underneath you can find Ag, which is silver, and underneath it the Au, which is gold. You know that gold, for example, does not react with oxygen, right? Even silver takes several months to react with oxygen, but copper has higher activity than silver and gold. But I just wanted to give you an idea about when you go from the left side of the first transition series to the right side in the first transition series, you can find that the reactivity of the first transition series decreases. And that's it. If you liked the video, please hit the like button, subscribe, and comment below. See you in the next video. Bye.